There is some problem actually, I think. Yeah, now fine. So basically what we have discussed, we have emphasized or outlined the two frameworks, and these two frameworks are basically there to have an idea that okay, we could have a model, we could have a process, we could have a system for searching something. It could be searching for a food source, searching for information, searching for any object, right? So when I say object, it means it is the atomic object. Like it could be a document, it could be a result, it could be a file, it could be a website, right? Anything. So naturally, when we process the data, process the information, in the bottom level, we will have these objects. Right? And naturally, whenever you are planning to retrieve that object or document, we will perform some pre-processing. So suppose you are dealing with the document sets. Suppose you are having a PDF file or maybe any article release, research article, or maybe any website where text data is dominating. So whenever we have an object with this kind of details, during pre-processing, you tries to come out with maybe set of terms, set of keywords, set of frequent keywords, something like that. So all those kind of data is referred as surrogate data, right? It is important term. So surrogate data means it is kind of summarized details from an object where the processing will be applied. So whenever we will performing matching process, matching between query and object, this matching will be performed between this query term or query word or maybe any keyword from user query, and this matching will be based on this keyword from user query along with this or comparing with this surrogate data or surrogate part of information, right, which is created based on some pre-processing. So this is kind of internal concept. We will be talking about this part. So in the previous class, we have taken these two frameworks basically, and these frameworks are there to highlight the importance of two aspects, importance of two focuses while designing a search process, right? When we say berry picking, it means it is there to highlight the importance of focused search, right? So whenever you are trying to build a system, create a system, design a system, you should have some mechanism to help the user so that he can perform, he can spot on, he can narrow down to a specific portion of information within the document, within the particular object. Similarly, on the same system, we should also have some mechanism through which user can explore, user can browse onto the other relevant, other retrieve, maybe document, maybe results, maybe anything, right? So when you are creating a system in nowadays, actually, in the modern search system design, it has been suggested that you should have balance between these two behaviors, berry picking and food foraging. Means it is talking about balancing between exploitation and exploration. That's what. You can always have a system which is entirely based on berry picking. That is one thing. There are many systems available in the internet itself. If you search for systems like Just Dial is also a platform. So Just Dial is entirely based on berry picking. And if you go for food foraging, your Google Scholar itself provides some sort of mechanism which is entirely emphasizing on food foraging or exploration-based behavior. But if you are designing a search system or retrieval process, it is suggested that you should have a balance between both, right? That's what is the suggestion. So based on this, because from today we are more or less talking about the design part of such system, right? Till now we are talking about the different basic or fundamental concept, fundamental ideas, fundamental you can say the terms or related things. But from now we will talk about details related to the search system design or maybe IR process design. So whenever we are talking about the designing a system, designing a process, you should always have two views, two perception actually, right? So those two perception we will talk about, like it could be a designer view and it could be a user view. So whenever you are designing or planning to design a system, you should always have these two views, right? First view is obviously designer view because you are acting as a system designer, right? Along with it, you have to, you know, you have to have a capacity of looking at the same system as a user point of view also. Then only you can be a good system designer. That is for sure, right? I'm sharing these two facts with some sort of convinced kind of position because I have been there in the industry for 4 years and I was working as a database designer, right? So designer, the responsibility of person who is looking into a designer or designing kind of responsibility, that he should have these two point of views on the system, right? So suppose you are creating a database, suppose you are creating a system, you should have both, perception, both point of view, both uh, you know overall view on the system side. So one day you may be acting as a designer, second day you may be acting as a user view. So when we talk about or when we emphasize the user view, it means you are also observing behaviors of the search system or design system with expectation of user, right? What will be the user expectations in the future from this system? So by that you can validate the designed view of the system, right? So naturally, after getting into these two views, we can talk about the different elements, different computing elements, computing blocks in a search process, or maybe in the search system, or whatever you see, right? So let's start discussing about these parts. So these essential part we have discussed in previous lecture. Now we are going much into the designer point of view or designer phase or designing phase of the search system, right? So obviously this is what is a fact actually. It is said that search and communication systems for searching, system for communication are the most popular usage of computer and internet. So this is just a fact has been added. It is not having any direct relation with the current topic we are discussing into, right? So this is just a fact actually. Now, I mean, because we are talking about the different concepts related to the search system, now let's take a basic definition first, then we will talk about the different components that you can also tell me, right? So search system is a field, I mean, designing the search system is a field concerned with structure, analysis, organization, storage, and retrieval of information. So you can see here, retrieval of information is one activity in the search process. So this is just a definition taken from a certain textbook actually, and this emphasize primarily five core processes, core computing processes which are to be there in within a search system. So I mean, at this point of time, you can call it a search system or search engine. I do not prefer using this term engine because it emphasizes some sort of a system view, which is more or less kind of a physical system, right? Maybe electronic system, which is having some part integrated with hardware and some part with software. So whenever you call a function, whenever you call a task for search, it integrates like it is a mechanical task happening in the background, right? So that's why whenever I wanted to explain something about search process, search system, I do not refer or do not prefer to take this term called search engine. Search engine is something we are often we are used to use it while discussing about searching process, because in early days of computer evolution, engine was the preferred term which has been taken by different person for different perspective. Like maybe steam engine, maybe any engine, right? So whenever we say there is something which has been happening automated fashion, we used to call it an engine, right? So that's why in early days it was preferred to consider the name as search engine, but nowadays it is not, because we are now having more sophisticated terms, and based on that only we are having this search system term, right? Now what we are emphasizing, that whenever we are trying to design a search system, it will be dealing with some sort of structure, maybe structure of a document, maybe the structure of data, structure of details which is available, right? We will analyze, not we, the search system itself will analyze this structure, utilize some details, and organize them. So organizing, maybe it could be a kind of task where we will be generating or extracting some keywords and placing them in a vector space, right? So organization means you are again arranging, or placing the pre-processed data from all the documents into some syntax, primarily you can say. So space is something we are using whenever we talk about search system, right? Because any search system which we have designed in the last few years, maybe 10 years, maybe 15 years, 20 years, each and every such system is having structure, organization, or syntax where it is, placing all the stored document, and after placing it on organization, it creates some sort of structure to store in the physical systems, in the hard drives or in the servers, right? So this space term is there. Space is space term we are using just to indicate, just to highlight that there is a conceptual, if you take this terminology, space in the search system and schema in the database, both are equivalent, right? So in the database, whenever we are interested to create a database system or database, we used to create schemas, right? Maybe in the relational database, the schema could be having impression of tables, right? But the data in the case of database also is not going to be stored in the physical drives in the form of table. There is no structure exists in the database servers, in the database drives of table structure. In the bottom, in the physical level, on physical drives, the data will be going to store in either tree data structure or graph data structure or hash table data structure, right? So there are different data structure is being used to store the data, which we are assuming as a user, or maybe as a programmer, that data is kept into the table structure. So the table is a kind of conceptual organization for the data. So whenever you fire a query by using SQL, that query will naturally give you some results, some tuples on the columns, different columns. So whatever representation we see, whatever organization of data we see in the systems, it is called organization, right? It is always there in the middleware, in the middle layer. Like in the database, we have observed 3 levels: internal, then middle, which is called conceptual and logical, and then physical, right? So these schema structures are being kept in the middle level, right? So you must have, or if you can recall, in the database design, we have a storage called metadata storage. So there we are keeping all these schema definitions. I'm precisely using term schema definitions. So whatever you are writing, like create table T1, where name, first name, last name, DOB, and along with their data types and their constraints, whatever definition we create, it is naturally compiled. So whatever you create through DDL, that schema definition is kept in the metadata table. Similarly, in the case of such system, there is this conceptual organization, conceptual view of the data. and that's what we are saying as a space. So sometimes it is called vector space, sometimes it's called some other space. So we will be getting into this part maybe in lecture 15 or lecture 16 around, and it is one of the critical aspect of such system design, right? Because it provides a linkage between the actual data stored and the data with which we will be interacting, right? So it is coming under this organization part, and naturally we will have a server to store. So there we will have actual data or information object stored. It could be your hard drive on your system. It could be a server. It could be some warehouse. It could be a data mining kind of hardware devices interacted. And eventually, once we have all these four elements on the place, we will have a mechanism to retrieve the information. Now, why it is kept in a altogether different component? That's the catch actually. Like in the case of database system, we have a very rigid structure to fetch the data. So if you submit a query, it will be fetching some of the tuples based on the mention condition on your query, and it is entirely based on exactly matching, right? There is no deviation, there is no probability involved. But in the case of search system, it is not the case. In the search system, there are few such systems available which asks to get the exact data, the information object. But most of the search systems are working in the mechanism of, a relevance-based retrieval. They assume that the query which user has submitted is not exact, it is not precise. So let's retrieve the document which are also partially matching, partially relevant also. And there is the concern. That's why we are having a different retrieval aspect involved, right? So this is what I mean. These are the things which are reflected in the definition itself. Now from here, actually we are moving towards from search process to search system. That's why we have taken all these elements. So if you talk about these 5 elements, it is primarily having this larger view of system design. So we are not only talking about now search process, right? So that's what I'm saying from the very first day, that search system and search processes are two different focuses. So if you take a website where this search process is provided, search is provided, we cannot say that it is a search system, because it is not having, that website is not having dedicated structure, analysis, organization, and storage, computing blocks, processes for this simple search task or search process. It is not a full-fledged website design, or maybe they are not having a full-fledged entire module to support all these 5 steps, right? So that's why we are saying it could have some ad hoc mechanism to search, to perform or conduct the search. That's why whenever we observe search as a process, it is often not accurate. It is not often fetching the required details for you. But when we have such system like Google search system or Google Scholar, MSN Search, Microsoft is the owner now. There are many search systems available which are designed for designated this entire 5 element, right? So now our focus is going towards the designing of such system. It means it is talking about creating all these 5 elements, right? So if you can recall, based on whatever topics we have discussed till now, whatever things we have now elaborated to you, so if you want to list down all the components, so you can read here and you can suggest me if something is missing. So naturally, if you are trying to design a search system, you need certain components. It could be a hardware also, it could be a simple GUI also, because GUI is something which we are placing as the first element. Maybe interface, maybe a graphical user interface. Sometimes it is called user interface. So that will be the first element we should see, right? As a user actually. Now, I mean, that's it. So if you have a user point of view on the system, this is something you can ask for. I need a GUI to interact with, to provide my query, to see the results actually, right? After that, now you have to switch your role. So now from this point of view, you can observe that, okay, now from now I will be acting as a designer, system designer. So from that point of view, you can list down few elements. Like for pre-processing, you need few components. Like it could be a crawler system, not system, crawler program. You need a matching program. You need an indexing program, something like that. Then within matching, or maybe specifically in the matching component, we need matching and ranking mechanism, right? So this matching is different. This matching in the pre-processing, it is different from the matching component here, right? So this is talking about during pre-processing. This matching means you are there, or maybe your algorithm is trying to identify all the possible related documents in the internet at the beginning of system design, right? It is nothing to do with the real-time matching. Real-time matching means matching based on user query. So that's why it is placed under the pre-processing component. Now, matching here means it is talking about matching between user query, user input with the stored documents. And naturally, once you done with matching, once your algorithm or your equation done with matching part, next task is to arrange these matched results. So maybe matching is not exact, or maybe it is based on some other mechanism, but for each case you have to perform ranking. And why we are performing ranking? Because it provides, or it captures some sort of user importance, right? It could be matching based on some sort of scores. Whenever we are performing matching, there are some scores based on which the results are fetched. So you can have some mechanism for arranging or ranking these documents based on that score. You could have a explicit mechanism to rank the results, like number of views. Nowadays, in most of the websites, we are having number of views as one of the feature, as one of the factor. Based on, you can re-rank the results. It could be the date of addition, date of the data object introduction. So there are many ways based on which user can also re-rank them, but naturally there will be one way based on which system is going to rank the results, right, to the user. Like in the case of Google search, it is also providing these 100 or millions of results to you in some mechanism. Only top 10 results which are highly relevant. I am using term relevant. So those 10 documents which are highly relevant to the user query are placed on the very first page. Subsequently, there is an order of relevance based on which some results are placed on the 10th page, right? So that's why we need a strong mechanism of ranking. And in the case of database programming and SQL programming, there is no mechanism of ranking available, because each and everything is based on exact search based. If all the 10 or 20 results are fetched based on exact results, there is no need to order them. There is no need to rank them, right? So we will be coming up this part because in the very first generation of search system design, search systems are entirely based on the mechanisms of database system design. So the very first search system we had, it was performing equivalent to a database system based on exact match. There is no need of ranking. It was all the pictures were there. But as systems are being evolved over the years, nowadays we are having different mechanism to rank the results, right? Because this ranking part captures some sort of expectations of user, right? So that's why there are many mechanisms are nowadays available. And there is a specific field of research which is talking about, let's learn how to rank in the search system itself. right? So there is this thin area where people are working. So we'll discuss this part. For matching, you could have different similarity measures. So that is another area of research. People are working on this part. Now, after having these three elements, there is the element called database or corpus or document collections. So naturally, because in the case of search system, we will be having different documents which are existing in the internet. So we have to, store them eventually. So we should have a physical drive. Either it could be database like Hadoop database, something like that. It could be a proper, data warehousing kind of situation where we are having all the content stored in one corpus. And you could have a simple document collection also, right? So this is something is an important and mandatory part. There is, in some cases, there is a specific portion, a specific component which is taking care or capturing all these history logs actually. So logs means you can now understand logs means what. I mean, whatever interest you have shown, whatever queries you have pushed into the system, all these things are captured. In some cases, whatever results you have seen or you have viewed are also maintained, and it is for a specific purpose, right? So here there are two terms which are very precisely placed. It is called intent and interest, and you should look for these two terms. Why these two terms are different? Interest and intents both are different, right? So naturally, these are the things which in the very first go you should have. Now there are another 3-4 aspects which are missing here as a components. We will be coming about these parts and subsystems primarily. So these actually 7 or 8 things are called as components of the search system. So from here, whenever we say what are the components of search system, you should be having these names on your fingertips, right? So let's understand. So that's why it is written like it is evident that a search system consists of multiple computing units of such subsystems and interactions. So interaction is there because each and every component will be interacting with each other for some sort of task, some sort of data exchange or data flow, you can say. Each subsystem is intended to facilitate a specific purpose or a specific objective, right? In the information search, or maybe sometimes it is a data search also. So the immediate question from here is what could be the possible types of search system you can identify, right? So primarily based on the textbook classification, like whatever textbook we are referring for understanding the search system or information retrieval systems. These are the 4 types or 4 categories of search system existing, right? You can always suggest 5th or 6th one. So the first primary type of search system, it is the web search systems, which we are referring as a one of the example is Google search. Then we could have MSN search. I mean, we could have Yahoo search. We could have nowadays it is, I don't know it is working or not. It is Rediff search also. Rediff search engine was also there. I mean, now we are having a very specific search system like Google Scholar system, but Google Scholar is not of this time, right? It is a kind of it is called a vertical search system, which is basically dealing with a specific type of data, right? Like Google Scholar is only dealing with scholarly data, right? So whatever research papers are being published, Google has its own indexing mechanism, and these indexing mechanisms are maintaining the repositories of all these articles and provide the search facility on the top of it, right? So this Google enterprise, Google organization is having their own separate database, separate indexes for all these research articles, research papers, and on the top of it, they are providing some sort of search mechanism to the global user. Naturally, all the results which are appearing in the Google Scholar, they are also appearing in the Google search. So if you search for any research article in the Google search system, it will also appear there. And if you search it for the Google Scholar, it will also list there. Because your nowadays your main Google search system is kind of a meta search system. It is combining all the results, right, in one platform. All the results means all the type of results. It could be a search on images, it could be a search on videos, it could be search on maps, books, all the categories. So if you place these categories, right, like in the case of Google search, if you see for a query, you can see all the results in different categories. So it is becoming kind of vertical search. But your first tab, which is called the Google main search, it is a simple combination of all. So we can say it as a meta search. Though meta search is not the accurate term, because when we say meta search engine or meta search system, it combines the results of more than one search platforms. Like if you are having a system which combines the result of Google as well as Amazon, right? So if you combine these results from both search system and arrange them in one single interface, it will called meta search, right? Because meta means, again, it is simply combining the results of two search system. Your system, which is called meta search system, is not having own database, own indexes, nothing. It is simple integrating the results of two search system, right? So it is basically a superficial interface on the top of these many systems. So this web search is one dominating area or one dominating type of search system. After that, there is a specific category. It is called desktop search. So I hope you have experience with desktop search. I mean, Google is also providing desktop search. So like right now, I'm using my desktop system, and sometimes we feel, okay, there is a document which I'm not able to trace in my desktop, and it may be a simple Word file, it may be a simple PDF, it may be a text file, it may be an image also. So you need to simply search it for simply specifying the title or name, something like that. So by default, each and every operating system is providing a desktop search, a search mechanism, but it is limiting only for few file types, right? And that's why nowadays there are many desktop search based systems available. So Google is there. I mean, most of the organizations which are creating this kind of operating system, they are having their own way of tool for performing or conducting desktop search. So it is dominant, though we are not using these desktop search tools or systems on our daily life, but they are there. They are there actually. After this, there is a system which is called enterprise system. Enterprise search. So enterprise search is sometimes called federated search also. So when we say federated search, it means there is an instance when we are searching for something on your phone book, on your email, right? So it is often called, there is another term for it. It is called PIM, personal information. It is called personal information management actually. But whenever we are having this system on this personal information kind of situation, like your contact number, your emails, or maybe your other details, right? So when we conduct search on these kind of data, which is a very personal, very secure kind of data, it is often referred as a personal information search. And if we create personal information search within the organization, like if you're working on a company or an organization which is having 10,000 employees, now you wanted to search for the phone numbers of certain individual. So nowadays, each and every organization is having some sort of portal, some sort of tool. From there, you can get the detail of any individual employee. So there you can find the phone number, you can find the email ID, you can find the name, you can find the address, employee details, designation, each and everything, right? So because it has been largely utilized well within the boundary of organization, that's why it is primarily referred as an enterprise search, and it provides personal information search on the personal information, not on the globally contributed information part, right? and it is typically is restricted to organization. It should not be accessed. It should not be available to the public domain user, public or maybe individuals, right? There is this. Now, last category probably could be a peer-to-peer search system, right? So peer-to-peer search systems are primarily, and here you can assume that we can place all these recommender-based system here, because you can conduct the search, your search task on any object, like in the case of web search, we are not able to perform this kind of search, right? Because the information about the objects are little restricted, right? Like nowadays, Google search system is integrating somehow the results from Amazon, results from the Flipkart, whenever you type certain product, but it will not help you to navigate through these objects, right? So peer means peer-to-peer search typically helps you to navigate through these object level search tasks actually. So there are many examples for it, and there are few, though there are few limited systems available for this for generic purpose. So these are the four dominating application domains, primarily you can say, or the types of such system existing. There are few which are not being developed till now. They are not being available for public domain, and that's what we will discuss during your last topic of last chapter of your this course, which we are seeing as a advanced paradigm for information search. It could be a search for social platforms, social media platforms. So that is called social search. There is another paradigm which is called question answering based system. There is another paradigm which is called cross language information retrieval, right? So there are 3-4 situations which all we will be covering in this semester, and those all are falling in this last maybe category, right? So with this, let's have a basic idea that how we can design a system, and if you are designing a system, acting as a designer of a system, you can also have a basic point of view on a search system. So this is just a example. We have one of the MTech scholar has designed a system who's working with me. I think it was 2017. So she has designed a system that primarily captures most of the. I mean, she has designed a system which has primarily some work has been done on most of the components of a search system. So this is what we are referring as a designer point of view, designer perspective on the search system. So you can see here most of the components has been placed on the rectangle box, right? So be it input section, be it history management, or maybe keyword section, ranking model, result section, view results, or sometimes it is called automatic interactive or automatic interaction, right? So if you carefully go through this particular image or figure, you can see it start with user. User is submitting some query into the input section. There you can provide simple query box. And naturally, if you're designing a system for modern usage, there are very specific details written here which are not generic, not relevant to a generic search system. Like in this situation, during this input section or at the input section, user can start searching, or there's a button to end the search. So that is not a very related to the generic search system, but there is a need of query box. There you can submit the query, right? And whatever query you enter, that query will go to two portions primarily. One is naturally it will be listed on the history portion or history section or history data set, whatever you say, and the same query will be sent to basically a module which utilizes it to retrieve the result, right? So there may be a simple portion or separate portion which can list down all the keywords, all the queries. So it may be not specific to the Google's kind of search systems. So whatever system we have designed during 2018, it is having all these elements. So whenever user entered a query, that query is listed into the history section, as well as it is also listed onto a section which we are referring as a keyword section, right? So this keyword section provides some sort of view on the previous query keywords and the keywords which are appearing right now in the results, right? So whatever query we have submit, it is primarily utilized by the ranking model. So directly the query which we have submitted here, it is being utilized by the ranking model to fetch the result, to rank the results. So once we have submitted this query into ranking model interacts with the naturally the backend data, backend corpus or collection to get all the result, to retrieve the results, and it is the responsibility of ranking model to arrange or order these results based on some importance, based on some view which can be suitable to the user, right? So your results may be displayed in the list view, like here we have shared a brief snapshot of it, right? So rank results will be displayed, and if you are interested to perform something on the result, these basically results will be re-ranked based on your interaction, right? That's what is called incorporating feedback to re-rank the results. So the results which I have retrieved for very first query may be revised based on user interaction on the results, and that is the role of re-ranking model. That's it, right? So this could be a continuous iterative process, iterative arrangement. And this is what I'm saying, this is what we are not having in the Google search case, because Google search system is a very generic search system. We cannot provide these kind of mechanisms there because it is being largely utilized by the world users. And this system which we have designed, it is only having some specific use cases because it is mainly operating on the research articles, right? So this is just to get an designer view. Like suppose you are also planning to design a search system, you should also think about these different elements, how you can place them, how you can have an interaction between two elements to certain purpose. So this is what one point of view on the search system. And now in the very next moment, if you are using or utilizing or operating a search system as a user, there also you can have a second point of view, right, as a user. So what we are emphasizing in this diagram, we are emphasizing this is again a different system. It is not same as the previous one. So here this is another system which we have designed, and it is called intent view system, and here there are few details available. We are not able to see any component because as a user you will see only GUI and their different modules or different section in the interface about the data, about the result which we are interested of. So now let's take this simple GUI and try to understand what it is providing, what is the capability it is providing. So here there is a search box available here where the computer vision is submitted as a query. So once you push this query into the system and search, click on search button, system fetches different relevant results. In the first go, it provides you the list view. In the right side, you can see the different articles listed here. So the very obvious thing is that as a user, you are interested to see what is the top 10, top 5, top 20 matching results for my query. So you can provide a list view in the right side. Now, do you see any possibility of re-representing the facts in a summarized way so that user will be feeling more confident, more informed during this search task, right? So from here, what we have done, we have provided in the left side portion of the interface, we have provided a kind of radar view. Radar view is there to capture the two-dimensional position, two-dimensional aspect, two-dimensional relevance aspect of a keyword. Now each keyword appearing here like vision, research, perception, robotic, polar robotic, then tracking, then object recognition, that you can see there are different keywords appearing here. So all the keywords which are appearing in these 3-4 layers, within 3-4 layers in the inner portion, are considered as matching ones. These keywords are appearing on the documents listed in the right side, where the keyword is exactly appearing. Query keyword is appearing exactly on those documents. These keywords has been taken out and arranged in the inner portion, like these 3-4 levels. Naturally, we are placing vision in the closer one because it is closely matching with the user query. And we are placing this reconfigurable computing, then research, then robotics, image processing in the little outer portion. So this is just the placement of keyword here shows the matching or maybe relevance of a keyword with respect to user query, right? As well as it is also placed here because of it is appearing into a document which is matching, right? But matching with lesser score, something like that. So it captures the relevance estimation, relevance score, right? And all the documents, all the keywords appearing in the outer strip, these are coming out of the documents which are not exactly matching to the user query, but they are considered by the system as relevant. So this gives a kind of broad, because in the list view you can see as a user only few limited results. But by having this view, you can have an idea that okay, these are the terms, because by looking at the terms, keywords, as a user you will feel comfortable, convenient to operate. So this is one part. This is what, so whenever we are providing this kind of interface to the user, you should always have an idea. You should always give an idea to the user that okay, we will be having this list view. In the left side, you will have a graphical view. There, the keywords are placed based on this estimate, based on this idea. Now, what is the next extent you can provide on the same GUI? Here, you can provide some mechanism so that user can play with the keywords. So, if user is interested to search about tracking or perception, if your interface is providing some mechanism to play with, like in our case, we have simply provided drag and drop here. So if user is interested to drag this perception in the inner portion, he select that keyword and drag simply into the center part. And our system assumed that it was a positive feedback, right? So, I mean, there are many mechanisms, there are several mechanisms to model it, because when the user is dealing with or touching upon a certain keyword, your system or it is your responsibility to capture its point of view, its importance, its weightage during the search task. Because you have started with computer vision, but now in the second iteration, you are interested to see about perception. And this perception is naturally already in the first result set, but now you're emphasizing your importance on this keyword. So it should be having some weightage. So once user drag a keyword and place it in the center portion, the entire result will be naturally revised. All the keywords will be now changed, right? So this kind of mechanism we can provide. So because by this, whenever we see as a user perception view or user point of view, you should think about all the possible expectation of a user can be captured, whether it is possible to capture all the expectation, whether we can provide some sort of mechanism to operate on to deal with this information, modeling kind of thing, modeling of user expectation. So this is what, I mean, we can have two extreme of system. One system is search system where like we have Google search system, which is not having any feature on the GUI. It is providing simply what? Search box and enter button. And based on that, it is generating results. Based on your interest, you can take out one of the results. In the second stream, you can provide, along with the results, you can provide some mechanisms so that user can directly operate with. User do not need to enter a query in between, right? So this is what we have designed during 2019 actually. And there are many works which has been published based on this kind of system. We will be maybe in some lecture we will talk about this part. So this today's lecture we have shown you these two point of view so that you can, in the coming lecture, when we will talk about each and every module, you can have a broad idea that it may be coming because of this point of view. This module is placed here because of this point of view on the search system design, right? So that's it for today's class. Now, if you have anything to raise, any query, probably you can take the time is not there to